Hi, welcome to the first video in a series of me trying to create a game engine in Java. It's going to be a 2D game engine, and I'm going to use all the concepts that I'm learning currently in my university. So I'm Calvin Rivers. I attend the University of the West Indies, that's in the Caribbean. I'm currently pursuing a bachelor's degree in computer science, and this is my final semester. So the course that I'm doing this for is game programming, and it's more like an introduction to game programming where we gain an understanding of, well, how frames work and the entire rendering process, moving objects all over the screen, creating those interactions, kind of like creating a game. So my prior experience with game development is that I created a game engine in JavaScript. So back when I was younger, a teen, I used to watch videos on YouTube of how to create video games in Flash. That's Macromedia Flash, Adobe Flash. And we used the language ActionScript 2. Now that has sunsetted, and I moved over to JavaScript because the syntax was really similar. And I created my own game engine to kind of mimic some of those functions and features that Flash had, and that was in JavaScript. So now I'm doing a course in game programming where we're using Java as the language. So I'm taking it as a mini project or challenge of myself to kind of, we can say, port the FlevaR game engine into Java, and the limitations I'm gonna set for myself is that I'm only going to use what Sir taught, well, as much as possible. So there already exists game libraries or frameworks out there that I can easily use, but I'm gonna try to build it with the knowledge that he teaches us in this course. And that's because I'm also unfamiliar with Java as well, and it will be really easy to just Google search and find everything that I would need because I have the experience of creating things like this before, but I want to set those limitations. Obviously, for things like data types like HashMaps, I could probably still go and Google the Java syntax for those functions, but in terms of like threads or loops or anything like that, I'm going to try to keep it working with what Sir has taught us so far. So before we get into that, I'm going to just give a brief overview of the FlevaR game engine that I created and some of the features there, as well as what I hope to implement in Java by the end of this semester and by the end of this course. So FlevaR is a declarative JavaScript game engine to create 2D browser games. It's an NPM as a package, and it can also be used with an editor that I've been working on. Now, the game engine tries to make the developer's life easier by handling many things, such as rendering, hit tests, loop handling, save and loading, sounds, etc. You can see that here. So it creates a canvas-based FlevaR clips, such as text fields and prefabs. So I call them JevaClips. Those are essentially going to be the game objects or the entities, as you can call them. FlevaR also manages textures with graphics, painting, sprites, and sprite sheets. Now each of these are different things. Graphics are actually the images that you will import or load into your application. Paintings uses JavaScript, the browser's API for Context 2D drawing to kind of dynamically draw graphics on the screen. Sprites, you can draw a painting and save it once, so it wouldn't dynamically draw each time. You do it once and that's a sprite. And then sprite sheets, well, it's an image that you kind of border, say it's a really long image, you split it up into a few sections, and each of those will be different sprites. You can create them as sprite sheet. So for our JavaScript implementation that I'm going to try and port to Java, I hope to at least have the graphics module just being able to load images in the game. I'm not sure about all the other appearances as yet. Now, FlevaR also handles audio with sound. It uses the browser's audio APIs, but I kind of extracted it into a module called sound. So I'm not sure if we're going to reach that far in our course, but if we do, I'll try to do the same in Java. Now, there's simple scene manipulation, and scenes are a bit like frames where Flash was. So you're going to create game objects, you're going to add them to scenes, and each scene will have different objects. So when you decide to choose scene 1, like a menu scene, it's going to load in all the objects in that scene, like the buttons, any art, any text that says main menu. Then if you load a second scene, like main level, it first has to unload all the assets and objects from scene 1, and then load in the player and everything else that will have been attached to scene 2. So scenes will act like this separator container that also helps with memory management, since we don't want everything on at once. And there's also a virtual camera in my game engine. So if an object is to be drawn 10 pixels to the left, but the virtual camera is offsetted by like 5 pixels to the left, then it's going to be a difference of 5 instead. So it's kind of like a mini camera, a virtual camera in that world. And it handles things like rotations and skewing with width and scale. And I'm not sure if Java also has an API that I can use to make that easy, because what FlevaR does is it handles all the rendering for you. So all you need to do is say, hey, I have a game object at this position, with this size, and it looks like this image. And then the game engine itself will draw that for you. You won't have to worry about that. You give it a different rotation or with a height or scale, and the game engine handles that for you. So I'm not sure how far I can get with that in Java. We'll see if rotations works as well. Now, FlevaR also has saving and loading. So it uses the browser's local storage or IndexedDB if it's available. And I just wrapped it in a module called shared objects, which is really similar to what we did in Adobe Flash. I was just trying to copy that syntax. So if we get around to saving and loading progress in the course for Java, then I'll see if I can wrap it in a similar shared objects module as well. So those are the main features of FlevaR. You can see the asset preloaders as well built into it. So FlevaR by default, when you create all the graphics that it has to store in its library, in its internal library, it will kind of create a loading screen for you, so you won't have to worry about that, where it loads all the assets like that. Now, there are also some game object collision detection internally using a hit test function. So it handles rendering, it handles its own runtime or loop. That's where you can add different scripts to different objects, and the engine will call those scripts over and over for you, those reusable scripts. I'm not sure how to do that in Java yet, and I'm not sure if we may do that in this course, because in JavaScript, essentially, it's passing a function as a parameter, and it's kind of like a callback, and then the engine internally will execute that function repeatedly. I'm not sure if there's an equivalent in Java. And built into FlevaR is also many different input modules like mouse, key, sound, shared objects. So mouse and key uses the event listeners from the browser and kind of wraps it in a module. So you can just say, you can just try to get the mouse's X position and the mouse's Y position. Similarly, you can be able to check if the left key was pressed, the right key was pressed, and you can be able to do all of that inside of your script. You won't have to worry about handling that yourself. I think for Java, there are also different listeners for all those different mouse movements and positions and stuff. And once once we get there, I see how that functions, I try to create those modules as well. So those are all the built-in features. And there's also a documentation and a guide for the FlevaR application. Documentation has a lot of different details and all the methods available for the different functions and the conventions of the game engine. And the guide actually is a general overview of trying to get this to appear on the screen, showing you a bit of the code where you create some sprites, create a prefab with some options, create a scene, use that scene, and you set the world to green. So you just tell it what to do. So create this prefab with this X position and Y position. Notice no width and height was given because that was created by default, set by default. And we use the first sprite appearance, which is just like a default appearance. We give it, add it to a scene, and we use that scene. So in this scene, this prefab was added, and this is how it looks. It's at this position, and that's how it goes. So we're going to try to create something as close to that as possible in Java. And we can see over here, this is what we're going to try to get it to look like. We're going to, the game developer is going to include our game engine package into their Java code. And in their main method, they'll initialize the engine, which will handle creating the frames, creating the panels and everything for them. Then it'll also create some game objects, which will add it to the internal library of the engine. And for now, I'm not going to worry about adding scenes. I'm just going to attach it to the main screen that you can see right away. And well, for now, I'm just also going to have a render engine method that is exposed publicly. That's so that it just draws everything on the screen. However, in the future, when I figure out, or when we cover how to do loops or threads, I'll try to create that built-in renderer that renders all the objects that's loaded for you, so the developer will not ever have to call this render engine. So this is what I hope for it to be. Notice I'm going to call it JevaR, which is Java flavor. Well, though I think I can also call it FlevaR Java, but that's longer, so I'm just going to call it JevaR. So to begin, I'm going to make this code a bit smaller, and this is going to be an overview of my thought processes as we're trying to get everything game engine worthy. So you see all the mistakes I make, as well as all the research I'm going to do on the way, because I am also learning as I'm doing this. So what Sue has taught us so far in Java was more of the concepts of a different screen, where it's a bit different from what we're accustomed to with math, where the top left corner of the screen is x being 0, y being 0, and x increases while an object moves to the right, and y increases when you go downward. So just to demonstrate that, just pull up this paint tool real quickly. But let's choose some colors and draw a rectangle. So we're also going to fill it as well. We'll give it an outline. So let's say this is our screen. Okay. The top left corner of this screen would actually be x is 0, y is 0. Now let's just say that this scene is 600 in width and 400 in height. Then to the top right corner of the screen, the x will be 600 pixels across, and the y will still be 0 pixels because it's the top of the screen. Now the bottom left corner of the screen would be a y position of 400 because it's 400 pixels down. Sorry, it's an x position of 0 and a y position of 400 because it's 400 pixels down. And then the bottom right corner of the screen will be 600 pixels from the left and 400 pixels from the top. So it increases in, x increases in this direction and y increases in that direction. Inversely too, when we start going in the opposite directions, we get into the negative number. What Sue would have also showed was an alien object, but I'm just going to draw a circle to represent that alien object. And this object is somewhere on the screen. Let's draw a square instead for simplicity. Now, the top left corner of this object is its position in the world. And what we're going to do is try to move this object by moving its position in the world. And what he also showed us is sometimes when we move the object, we don't see it changing on the screen just yet. And that's because there's a bit of a difference between having the information for the object and then the screen having the information of where those pixels exist. So when we created the object initially and we said, hey screen, this is my object, draw it like this from this position, it's going to draw that box at that pixel size. But the screen will forever maintain the information that these are the current pixels and this is the information. Now, when we want to change the position of that box or increase it, which will move it to the right, we haven't yet communicated that change to the screen. So the screen will still have it represented like that. So internally, we know its position has changed, but we need to represent that. So we go now to the screen and say, hey, I've changed my position, I'm over there. And well, if we just try to draw it again, we may get duplicates. We first need to completely remove the previous position. So you need to wipe out where it was before. And then we need to redraw it in a new position. And then if it moves again, well, we need to wipe it out again. And we need to redraw it again. So it's a method of wiping where it was before and then drawing out where it is after. And that kind of simulates the effect of motion. Now, it becomes a bit, I would say, painstakingly tedious and clunky if we have each object trying to erase their own path. Because if two objects are on top of each other and one of them erases the area that it used to be, it might end up clearing some of the pixels from the previous object. So the best way to deal with that is to erase clear the entire frame and then redraw all the objects in from whatever positions they would have been. And I think that's what he's gonna show us soon, but he just showed us this simple process to help us gain an understanding of what happens, and we're gonna gradually optimize it. So I'm gonna start going through some of his code for the last session I would have taken. And well, you may argue that it looks like noob code and could be much better. And I agree. And he also agrees. So it's him just showing us how things are right now. And then as it develops, he will show us how to refactor different code. And I will also try to refactor the game engine based on new things that upload. So let's just begin by creating the main game engine class, and it will just be a Java class. So that's going to be the main class where everything is handled. And it's going to have a constructor. Now, if you notice, the way that we want to call it is that we want to pass a width and a height, because we want a game engine to handle creating the frames for us. And I think that's called a JPanel. No, it's a JFrame, and then the JPanel is to do the drawing. So it's gonna accept the integer width and then integer height, and that'll be the frames there. So now I'm just gonna start looking at how Sir did his game window and kind of modify that as we move along. So his game window extends JFrame, implementing all these action listeners. I think that our game will, rather than extending a JFrame directly, we kind of have our own screen class to handle that. So let's create a package called JevaR Screen a Java. Well, it's a class, it's not a package. And this is going to extend JFrame. So this extends JFrame. And because it extends JFrame, I believe we have to import that. It's java.swing. So let's import all the Java swing functions that we would need. And let's just see how he uses this. So in this JFrame, we want some default properties on this screen, such as set title, set size, and everything like that. So let's create a constructor. So public JevaR screen, also gonna have the width and the height. And this time, so we want to set the size to the width and height. Okay. And we also want to set the title. Well, for now, we'll just set the title of this application to a JevaR application. Possibly in the future, we can allow the developer to choose a title. So we have that for now. Let's see what else we do with our JFrame. So we want it to be, we don't want it to be resizable. So set resizable false. Set default close operation to JFrame that exit on close. So we want it to exit right away. And finally, we want to set visible to true. Whoop. So one thing we also want to do is, I think I want it to be centered in the middle of the screen. Let's just test this to see how it works so far. So in our Java game engine, we want to initialize this game screen. So it'll be a private variable. It's going to be a Java screen. It's going to be called screen. And we initialize it when the game engine is created. So screen is equal to new Java screen. We send the width and the height, and that's going to handle creating it for us. Let's see if this actually looks. So in our game application, let's uncomment this line of code, and let's also import. So if we run this, we can see this game panel appears successfully. Let's just change this to be 600, like 400, and run it again. Yeah. So now we want this to appear in the center of our screen. And by doing that, I think we do set location relative to null. And that's just centered. And it censors it. Now, before we do anything else, I'm going to try to make it green. The way we do that is we add a panel. It's going to be the easiest thing that we're going to use to draw every single thing. We only want one panel because that's kind of going to be the screen representation and drawing everything. This JFrame is just metadata in our game engine. So let's see how he did the JPanel. He has a game panel, but it doesn't really do much things there as its own function. So we'll use it as a JPanel. So in our Java screen, I'm going to have a private JPanel. We would call it game panel. And then everywhere that this, I'm saying I'm going to copy the code to the main panel. So we're going to create our main panel as well. So in creating our main panel, we say game panel is equal to new jpanel. We're not gonna do any flow layouts or anything because we just have one panel on the screen at all times. And we also want that preferred size to be the width and the height. So it'll be game panel that set preferred size, new dimension, width and height. I think I'll have to import that as well. Yeah, it's JavaScript.awt. And we'll see what else happens with the main panel. We don't need to add any sub panels because it's going to be the only panel. And inside here, it sets the background color to pink. So we actually want our game panel's background color to be green. Color.green. You see it's also been imported. And we're not going to worry about mouse listeners or key listeners just yet. And finally, we want to get the content pane for this frame, and we want to add the panel to it. So I think above, you will have created a container for that. So let's also do that. So private container, game container. I think we have to import container as well. We have to add parameter. Let's just look into that a bit more. Container cannot be resolved to a tag. So maybe just import everything you can AWT. Yeah. So as I assumed it was an AWT package, and just importing everything there, solve that issue. So now where we actually add the game panel to the container. So let's say game container is equal to get content pane. And we're getting the content pane of our JFrame because this Java screen extends JFrame. So it gets, well, it inherits all of those methods. And we want game container to add, and we want to add a game panel. So that's us adding the game panel. And let's test it out and see if we have a green screen. And we do. So the game panel has successfully been added to the game frame, and it's not resizable. So it looks like that function worked. So now let's look at trying to create a JevaClip or a game object. And the way we're going to go about doing this, we're going to kind of provide a method where we let them create an object, we give it a label, an X position, a Y position, a width, and a height. And that object is not going to be stored, well, it's not going to be drawn on the screen right away. It's actually going to be stored in a library, an internal library that the game engine handles. So at a later point in time, if we try to add a similar game object to a screen or to a scene, it's gonna be pulling the details we would have previously stored from that library. So it's kind of like a component where you store it once and you can reuse that component multiple times, possibly with slightly varying information. So it looks like a method in the Java application itself, and we call it create JevaClip. So let's also do that. So let's create a public void create JevaClip. It's gonna have a string name, it's like a label, and then it's gonna have some dimensions, double y, double width, double height. I use doubles instead of integers since I can use floating point numbers with more precision on the screen. And I'm naming my property variables with an underscore first and foremost, because that's the convention that was used in Adobe Flash or Macromedia Flash. So you can name yours XY width and height, XY WH, anything that you'd like to. This is just personal preference. So when we create the JevaClip, there are a few things we want to do when we call this function. So we want to initialize an actual JevaClip. So we'd have to create that class. And then we also want to add that JevaClip to our game engine. And to do that, we need a library of all the JevaClips that was added. So let's create a JevaClip class first. So we're going to have a JevaClip class with a constructor that accepts the string. So it's going to accept everything here. That's for like identifying purposes. Well, the name is for identifying purposes. So later on when we try to hit tests and we want to see if it hits any object of that label, then we can say return true. So I think label is a better description to use for this. So it'll keep track of its label. And we also call it label here. So in our JevaClip, we're going to have some private variables for each of these. And let's don't forget the data type because it's Java, not JavaScript. And we're going to do that for X, Y, width, and height. And inside a constructor, we're going to initialize all of them. So this dot label is equal to label same with the X, Y, width, and height. So X, Y, width, and height. So now I'm making these variables private because generally in Java, so for what I've learned in object-oriented programming, you want classes, properties to be private and create accessors and mutators to get and set them. However, in JavaScript or ActionScript, we will work directly with that property function right away. So sooner or later, I'm probably going to make those X, Y, width, and height properties be public so that the developer can use them directly. It kind of goes against object-oriented programming with what we learned, but once you can understand why you're doing it, I think don't feel like all hope is lost. Don't feel like it's the end of the world. So that's why we're going to do it, because it's conventional with FlevaR script, with ActionScript, with JavaScript, and I'm just trying to recreate as much of that as possible. So now that we have our JevaClip here, to initialize this JevaClip, it will be as simple as saying JevaClip, and we call it a JevaClip, is equal to new JevaClip with all these properties that we have created. And now we need to add it to the game engine in a library. So how do we go about doing that? Well, first our game engine needs to have a form of library properties. So let's create a private library property. And for this, the closest thing I can think of replicating an object that has label, value, key value pairs in Java is a HashMap. So I want to create a HashMap thread. Let's just see what the syntax is for HashMaps. So it's from the Java util library, so I have to import that, and it's like key value pairs. So private HashMap, we're going to use a string for the label and a JevaClip for the value. We're going to call it JevaClip library. And that'll be equal to new. Oh, I think we should initialize it inside the constructor. So let's import that as well. Import java.util anything. So inside our game engine initialization, let's initialize that. So look, JevaClip library is equal to new HashMap. Inside this HashMap, now how we're going to use it, I think it's a set method, or no, it's not set. It's a put. So we're going to say JevaClip library.put, and we're going to use that label. So the label is going to be unique for each JevaClip that we add to the library. And that's how we'll be able to identify that. So we're going to put the label, and the value would be the JevaClip that we would have created. Now let's do some checks right away to ensure that it doesn't already exist. So if JevaClip library that is it has, or is it get? Get. So if JevaClip that get label, so if we get this and it is not equal to null, then we know it already exists. And if it already exists, just return. We don't actually want to create anything. Otherwise, if it is equal to null, it will pass a function, it will create that JevaClip and store it in the library. And that's what we want. Now, I think that would be it for actually creating this JevaClip. So we call a create JevaClip, we give it JevaClip 1, an X position of 30, Y position of 100, width of 150, and a height of 50. Now what we'd like to do is see this JevaClip, because currently it's just information internally in the game engine in its library. We want to actually draw that to the scene. And the way we're going to do that is with a function called attach JevaClip. Attach JevaClip will attach it to that screen's hierarchy so that everything attached on the screen will be drawn. And that'll also be inside the game engine media function. So let's create that public void attach JevaClip. And first we're going to attach a JevaClip by the label that we would have created. Or it's going to have a label, an X, a Y, and a height. Yeah. So in order to get the information, first we have to see if that already exists. I think it's better to just use the label. So first we have to test if that JevaClip already exists in the library. So in order to do that, we have to check. So let's get that information. So JevaClip, Jeva, bold, JevaClip is equal to JevaClip library.get by the label. Now, if that value exists, then it will not be null. If it doesn't exist, it will be null. So that's how we can easily check. So if old JevaClip is equal to null, that means that it doesn't exist in the library, so there's nothing to attach to the screen. So we just want to return a function. I think later on, when I learn more with error handling, I'd create some errors to say, hey, you're trying to create something or attach something that doesn't exist. That's an error. Fix that. For now, we're just silently failing it without any penalties, but probably sooner or later we'll add those errors. So if the old JevaClip is null, that means it doesn't exist in the library. Don't do anything. But if it does exist, then we want to attach it to a hierarchy, a screen hierarchy. So let's also create that. It's also going to be a HashMap, but it's going to be a JevaClip hierarchy. I think that's how it's spelled. And also remember to initialize that in the constructor, or we get a lot of null pointer exceptions. So if it does exist, then we want to add that JevaClip to the screen's hierarchy. That's a tough word to spell. Well, okay, then. What I'm thinking is, if we want it to be reusable, then we should not add the same clip, because we want it to be dynamic. So we kind of have to be able to clone that clip. So how we'll do that? Well, let's set some properties first. So double x is equal to the old JevaClips x value. Double y is equal to bold JevaClips y value. The same with the width, and same with the height. Now I think I'm getting errors because it says the field is not visible, and that's because we had it private. So let's just make these fields public, and it's accessible. And now we can create another JevaClip, and it's going to be the current JevaClip that we're going to use in the hierarchy. This is what we're going to use in the hierarchy. New JevaClip. So it's going to have a label of XY with an height show. However, one problem that would exist is if we want to add the same JevaClip from the library to the screen multiple times, we want to give each of them different unique IDs so that they're, so that they would be able to be differently identified, if that makes sense. So the label will be the same because it's that function from the library, and we're gonna put that in the JevaClip hierarchy, but we want to generate a different label. And for that, I think we want a form of a unique ID. It's kind of called like a UUID or something like that. And to create or generate unique IDs in Java, there is a unique ID method inside a Java utils method, and it generates we can say toString and generate a string of a unique ID. So you want to generate a unique ID. So even if we create and attach multiple one of the same JevaClip one to the screen, each of them would have different ID representations. So I think rather than using this function directly, this code directly, I'm going to wrap it in a method. You might think it's a middleman method, but the benefit of that is if I decide to use another way of generating an identifier, then I wouldn't have to go everywhere that I try to generate a unique ID and change that code. I just have to change the code from the utility function I would have created, and it will be applied everywhere. So let's actually create a Java utility class. We call it Java utils. And it'll more just have some static variables, static methods, sorry, that does everything. So public static string, because it's going to return a string, generate UUID, generate unique ID. And it's going to return a string. So I think we can just copy this code and return the UUID as a string. We also need to import that package, to import java.util.uuid. So we're creating a unique ID from a random list, turning it into a string and returning it. Now, rather than having to do this entire thing, we can say just return UUID.toString. We don't have need for that second method. And rather than creating this like that, we can either just say return UUID.frontID.toString. So it's more of a one-liner. But I think for readability, we can leave it as it was before. In Java, when things are compiled, it's down to bytecode or machine code and virtual machine. I'm not sure if in the more lines of code would mean it's slower, but that's not something I'm really worried about for this game engine anyway. So we have this utility function generate ID, and we're going to use it down here. So we'll say string ID is equal to Java utils dot generate ID. And because it's a static method, we did not have to instantiate any utility function there. And this ID is what we use as the label. So the hierarchy will have all keys as different unique IDs and each clue and JevaClip representing them. Now, we've come this far, and what we want to do ultimately is be able to, I think attaching the attach function will work. But now I'm thinking, what if I want to attach something to the screen, but I also want to overwrite the X and Y position rather than use the positions that was defaulted in the library. So we want to use everything else the same with the same height, the same labels, but we want to override the X and Y position. So I'm not sure if it's called overloading or polymorphism or overriding, but in Java specifically, we can create another method and give it some more properties. So it's going to have a double for X and a double for Y. And we would not be using the X and Y from the old JevaClip, but we're actually going to be using the values that the developer sent to the function. Everything else will be updated from the old JevaClip, and we will be adding that to the hierarchy. Similarly, if we also wanted to overwrite a width and a height, we can copy this function again. It's also going to have a double width and a double height. So we're no longer going to be using the width and height from the library, but just going to be using everything else. Now, since I think this is the penultimate way that this function will be expressed, I think we can do a bit of refactoring before we move on, because there's a lot of code duplication. What we realize is the difference between the function with the label x and y. The function label x, y, and height is just the width and height variables. So in the original function, rather than creating all this code here, we want to use this x, y, width, and height that we got from the variable in the library. And we also just want to call this dot attach JevaClip with the label, the x, the y, the width, and height. And what that will do is after we get the x, y, width, and height from the code in the library, then we're just going to call this function directly, setting those values. And that removes all this duplication here. It's the same for the other variable. We have the x and the y that the developer would have sent, the width and the height that we would have gotten from the library itself, and then we just call it here. And so here we see we don't have to reuse much code, or at least we made it a bit simpler in terms of readability. So you see all these three methods with it. And now rendering the engine, we're going to try to get it to be drawn. So what FlevaR does is renders this default box, which is kind of just like one gray rectangle and one gray square and two dark gray rectangles. For FlevaR to do that, we want the clips to be able to handle their own rendering. So we're going to have a public void render function for the clip, and it's going to use graphics G. I think it's graphics G or graphics G2, but I'll just call it graphics G for now. And it goes without saying, but we need to import java.util. Is it not Java for graphics G? Or is it graphic? So let's refer back to Sid's code for a bit. In his alien class, he encodes. It's a graphics library. So it's the AWT. My bad. And you can see that the way he drew the mouth, which is a rectangle, is by using a rectangle double it. So let's kind of copy some of this code. And we'll also need to import some of these things. So it'll be java.awt.geometry and all. Now it's strange because I thought if we imported everything from AWT, it would have imported everything here because these are nested packages. But apparently that's not the case. So we also needed to import everything from there. So I think he uses G2, which is graphics 2D, and that is casted to graphics. So let's also copy that. So graphics 2D, and let's call it context instead. And it'll be CTX for context. And at the end, we will want to dispose this context at the end, but it would not be wise to try to dispose it for every single drawing. We can probably dispose it at the end after we've rendered everything. So this is actually sending the graphics to the context right away. And we will have a rectangle double, we call it the body, forward, and it will be the object's X position, its Y position, the width, and height. we set the color to create if it exists, and we will fill the object, the context with that body. But then we also wanted to draw the remaining objects, the remaining rectangles. So let's see how we would go about doing that. Now, in Paint, if the object is a square that's going to be a certain size, then firstly we'll pack. We know for sure this is going to be the X and Y. The top left is going to be the X and Y representation of the JevaClip. But then how wide it is going to be the width. How high or long it is going to be the height. And this will comprise of the entire sides. And somewhere in the middle, we want another rectangle going that way and then that way, so that they based on percentages of its width and height. So in theory, we want a light gray rectangle filling up this entire space, and then somewhere halfway in between, if I try to eyeball it, it's probably like, let's say 3 out of 5 or 0 out of 5 of the weight. Oh no, that's a bit before 3 out of 5. If this is 50%, then that might be 40%. So 2 out of 5 of the weight is 1/5 of the size and length. So we can probably call those different functions. So 2/5 of the way it'll start another rectangle. It's going to be as wide as 1/5 of the entire shape and as high as the entire shape. And finally, 2/5 of the way and height is going to have another rectangle. It's going to be this wide. So let's see if we can mimic these drawings. So we're going to have the body, which is the gray, light gray back. Then we're going to have the rectangle 1, and it's going to be the X position plus 2/5 of the width, which is width multiplied by 2 divided by 5. Now, since width is a double, this should work perfectly. So that's where it's going to be positioned, 2/5 of the weight lead. Now, how wide would it be? It would be the width divided by 5, which is 1/5 of the width, or width multiplied by 1 divided by 5. And it's going to be the same height as long. And then for rectangle 2 now, it's going to be the opposite. So it's going to start at X position 0, but Y position is 2/5 of the way down. So Y plus height multiplied by 2/5. And the same thing, it's going to be all the way wide across. So that's going to be its full width, but the height is only going to be 1/5 of the width. So it's going to be height divided by 5. So we set the color of the entire background, which is the light gray color, and fill it with this body. Let's see if we also have the same for dark gray. Yeah, so we have colored up dark gray. And after we set the colors of dark gray, we want to fill rectangle 1 and rectangle 2. So this is what's going to happen when this JevaClip is rendered. Well, by default. In the future, when we give it different appearances, this render method is going to be modified accordingly. But within everything, we want the engine to be in control of, or be responsible for doing everything here. So finally, now that we have how the object looks, our last goal is going to be looping through all the objects that is attached to the screen and rendering them out. So let's have a public void render engine, and now we need to loop through we attached JevaClips. So now how do we loop through HashMaps? So it seems like there are 5 ways to iterate through HashMaps. There's turning it into a set. There's a for each method. There's a while loop with an iterator, has next, and this looks complicated. There's a HashMap iteration using lambda expression, so it's kind of like a for loop again. And I read it. And there's more complex code. Entry set, stream, for each, input. Okay, that's really complicated. So method for looks simplest for each method. And it kind of looks the same as method 2. Let's copy method 2 using the for each to iterate through a hash map. And method 4 iterating through a hash map using lambda expressions. So it is basically the same thing. So we're just going to use this. What I like about it though is it looks really similar to arrow functions in JavaScript. So that's lambda expressions. So if I find out how to create methods that uses lambda expressions, then I'll be able to use this as the form of callback for scripts when we're going to implement our runtime and looping for our game engine. So I'll have to do some more research on this, but for now let's just modify it to use to loop through the hierarchy. So initially we want to clear screen, and then we want to loop through the hierarchy. Now, JevaClip.hierarchy for each key and value. We're not too, we don't really care much on the key, but each value there's going to be a JevaClip. And well, it seems like there's only one thing that can happen here. However, maybe if I go to telling in brackets, I can have multiple lines of code. Yeah, so let's format this entire thing. So for each hierarchy, we want to take the JevaClip, and in green, basically want to call JevaClip dot render. It seems like JevaClip can be resolved to a type. So, oh, I named it incorrectly. My mistake. And the render is not applicable because it needs a graphics 2D. So let's add the graphics 2D function. So essentially what we want to do is get the graphics from the game panel or the screen, and so we're basically saying, I am the screen, use my values to draw everything that you need to draw. That's why we're letting the engine handle everything here. So in our Java screen, in terms to get the graphics, we will have to call game panel that get graphics. Now I did not expose game panel to the game engine because it's a private method. So let's create an accessor for that on the game screen itself. So public, we'd call it graphics because it's going to return graphics. Get context. So I'm just using a bit of a different form of terminology, and it's going to return game panel dot get graphics. So now in our game engine, we have access to this private screen. We're going to do the clear screen in the future. Then we're going to get context. So for that, we call screen.getContext. And we're going to store that in our graphics objects. Graphics context is equal to string.getContext. We may need to import this graphics library, and we're going to send it to the graphics 2D version. So graphics 2D context is equal to context. Well, we're going to cast it. I'm just following along with this code over here. So there's graphics G panel get graphics. Well, our method is graphics context screen get context, because our screen get context is the method that returns the get graphics on the panel, and then we're just gonna cast it. We have to import this as well. Let's just import all the AWT stuff. Graphics 2D content. Now at the end, when we've rendered everything, we want to dispose of the context, and inside the JevaClip, when we're rendering them, we're gonna send that graphics 2D context. So what everything here does, so we're gonna clear the screen. So let's make this a to-do. Find out how to clear screen. So we're gonna clear the screen first. Then we're gonna get the context of the game screen itself, the Java screen. We turn it into a graphics 2D context, and then we loop through all the JevaClips in the hierarchy and render. We call the render method on all the JevaClips so that each of their individual random functions are called, which currently just has a placeholder box with a cross that we defined, that we fixed in the future, and then we dispose of the context at the end. So instead of disposing of the context inside this method, so we're doing it for every single shape. I just did it at the end. I'm not sure what implications this may have just yet. But it seems, I think everything should work now. So let's cross our fingers. For now, let's just test it out with one of the JevaClips. So we've created our JevaClip engine. I created our JevaClip at x is 30, y is 100, width is 150, and height is 50. Then we're going to attach that JevaClip using the same label JevaClip part to the stage. It's going to use all those default properties. What we call render engine, it should be draw. So let's test it out. And it is rendered successfully too. You can see that it's 30 pixels from the left. So that's like 30 pixels from the left. The Y position is 100, so it's 100 pixels down. The width is 150, so it's 150 pixels wide. And the height is 50, so it's 50 pixels high. And that's awesome. So let's comment this out and try modifying the X and Y positions forward. So you can see it's a bit off the screen, and that's because X position is 500. Let's bring that number down a bit, at 300. So you can see here that we use the same JevaClip, but it's going to be 300 pixels from the left, 80 pixels from the top, and since we did not define the width or the height, it inherits those values from what we stored in the library. And finally, if we try to modify the width and the height as well to just be 100, 100, this should be a square. And as you can see, it's 150 pixels from the left, 200 pixels from the top, and it's 100 pixels wide and 100 pixels high. So it's a square for us. So if we increment all these lines of code and have all of them together, then as you can see, they're all drawn. Each object is successfully drawn. And if we modify this code, so from the library, the default width and height is 50. You can see the default that hasn't been altered, 50, 50. And then the one with the width and height that was altered is 100. And it stretches according to how we defined it. So in our FlevaR, if we try to replicate a bit of this behavior, we create it with an x of 50 and a y of 100. X of 50, y of 100. I believe the width and the height may be 100 by default. And let's just use that one JevaClip and see if it lets us save as this. I think this screen is 500 by 400 by default. Oops, the width and height is supposed to be 100, not 10. That was really small. So no, it's a bit larger. So maybe it's 600 by 500 by default. Yeah, seems more accurate. I think the image is probably scaled up. But you can see here that 50 pixels from the left, 50 pixels from the left. 100 pixels from the top, 100 pixels from the top. And 100 with 100 height, 100 with 100 height. So you can see that this application is very similar. And now the beautiful thing about our game engine is we're going to handle most of everything. All the game developer did in just 4 lines of code was able to create this entire visuals that we see here. They just called the game engine with a width and a height. It was created for them. They created a JevaClip. It was added to the library. They attached that JevaScript to the scene, and it's been displayed. So they don't have to worry about rendering, drawing, handling the event listeners for mouse, keyboard input, or anything like that. All they're gonna do is just declare. That's why I call FlevaClip a declarative engine, because you just declare how things should be, and the engine handles making those things that way for you. So from developer experience, this is all they're going to do after importing the Java core engine, and the engine is going to internally handle everything else for them that they don't ever need to touch. So that's it. This is a successful Java application right now. I think what I'm going to do next is try to implement some form of looping, and that's because I'll need it with the mouse listener. So what we hope to do next is say Java mouse is equal to new JevaR mouse. Although I think mouse would more be like a static method or a static function. So it'll just be JevaR mouse. And we say if JevaR mouse dot is down, JevaR mouse dot left. So if the left button is clicked, then if we have access to one of the JevaClips that we created, we'll say JevaClip dot x is equal to 50 or something. So that's moving it around the screen. Or I think it will make more sense to use a keyboard listener. So if Java key that is down, Java key dot left, which would be the left mouse, the left sheet, and we say JevaClip dot x minus equal 10. Yeah. Else, if JevaClip dot is down key dot right, JevaClip dot x plus equal 10. So when the keyboard button is pressed left and right, you will see the clip moving left and moving right, as well as being rendered to show that continuously. So when I see how to do that, I'll focus on adding the key module next to make all those things happen, and the game engine is going to handle all of those things. But for now, that is the end of the first devlog, and you can see everything that I went through. So I hope that this was helpful or informative in some way. You can provide feedback or ask questions if you like in the comments section or wherever you know to reach out to me. And again, now this is not going to be the best code. I probably do a lot of things wrong, but it's a learning process, and these are the limitations that I'm setting for myself, because I've already also seen existing game engines and in Java and the different ways they do things, but I'm just going with what we're learning. So it's kind of like a mini project to use all that knowledge and build out this application. I don't want to stray too far from what's taught, so that in the end, if I do have an assignment, I can easily use this game engine, and it's not going to be code you copied from the internet, because I would have been the one that created it. So yeah, thank you guys for watching, and I hope you have a good day.